Hello everyone, welcome to AEDB Hub channel, your knowledge sharing channel and a DBA excellence. In this video, we are going to see Oracle to PostgreSQL, a complete migration architecture guide and architecture overview. It's all applicable for all the enterprise database migration and also cloud ready and zero downtime migration. Oracle database to PostgreSQL migration architecture. A complete walkthrough on step-by-step migration blueprint in this video we are going to see. From the assessment to planning through cutover and go live. So we are going to see one by one, and I am going to give a brief explanation and overview for this Oracle to PostgreSQL migration architecture. So here the Oracle database to PostgreSQL migration, and there will be a zero downtime. The CDC capture, CDC based cutover, and high performance using FTW and DMS tooling, and data integrity with row count and checksum. Also the scalable, it is working for the AWS, Azure, On-Prem databases. At last, that secure, it is the transport layer security TLS plus RBAC and enforced. Okay. So here is that I have prepared for that interactive migration architecture workflow. So we will see the one by one steps and all the view details and the scripts and the key considerations. On that left side panel, you can see that this is a source old system, Oracle, On-Prem, AWS, Azure. The database which is running on On-Prem, AWS, Azure. And the target side, the new system, it is PostgreSQL. So we are going to migrate from Oracle source database, Oracle database to target a new system with PostgreSQL, right? So on-prem Oracle databases and the database is running on AWS cloud and Azure cloud. So we are going to migrate on target system PostgreSQL with AWS, Azure, on-prem. Okay, vice versa. Like it is Oracle to PostgreSQL migration workflow. So in that middle panel, which is described the migration entire overall the process, migration process. It is from the beginning to post migration steps that go after go live, cutover, and post migration validation. The phase 1, phase 2, phase 3, phase 4, phase 5, phase 6, phase 7, and phase 8. Cutover and go live on validation. Okay. So we will see one by one briefly. Source side database Oracle, PL/SQL code, LOB data, BLOB and CLOB, indexes and constraints, sequences and synonyms, database links, triggers and packages, partitioned tables, jobs, DBAs, scheduler. The same thing on the target side, PostgreSQL, the PL/SQL, pgSQL code, it will be converted. PL/SQL code, it will be converted pgSQL code. LOB data, BLOB and CLOB converted to migrated data, BYTEA and text. And indexes and constraints, it will be new indexes, B-tree and gen. Sequences and synonyms, it will be migrated to sequences identity. And database links, it is FDW replaces DB links. And triggers and packages, it will be replaces functions and extensions. Partition tables, it will be migrated declarative partitioning. And finally, the jobs, DB scheduler jobs, it will be migrated pg underscore cron replaces DB underscore scheduler. Okay. So we'll see the first phase of this migration process. What is the first phase of migration process? Starts with assessment and planning. First, we need to assess. In this phase, the tools involved are to PG and type table, assess, AWS, and exachk. So let me click on this migration process phase 1. So this is the assessment and planning foundation phase, first phase, right? So what is the step-by-step involved in this foundation assessment and planning phase? First step, we need to run Oracle PG in assessment mode to get a migration complexity score. So while we are running Oracle PG in assessment mode, we will get to know that assessment complexity score. It will be 0 to 100. So if you are getting your report with 100%, there won't be any issues with that assessment mode, your migration complexity. With all the complexity fulfilled, we don't want to intervene anything. We don't want to do any complexity. If you are getting 75%, the remaining 25%, which is what are the key points we need to consider prior to the Torah to PG assessment, and we need to fix it manually to make it over to that migration complexity with 100%. And the second point, inventory all Oracle objects, tables, views, procedure, packages, triggers, sequences, jobs. So we need to take all the Oracle objects, take into that consideration. So all the table, all the Oracle key inventory, all the objects we need to take into the consideration. And the third point, analyzed AWS ASS reports to understand workload patterns and peak load windows. So in the source database Oracle, we need to analyze that peak workload windows timing and analyze that AWS reports to understand workload patterns. So how the database performing during the business hours and non-business hours, during the high workload and during the off-peak workload. So we need to analyze by generating AWS report to observe the peak load windows. Okay. And fourth steps that identify unsupported features, and it is by connect by row ID, Oracle specific data types. So identify these are all that unsupported features we need to identify, and that identified features we need to take into the consideration prior to that migration or to PG. Okay. And the fifth step, estimate data volume per table. Plan FTW versus DMS versus file-based transfer. So we need to estimate the volume per table. So the schema, which is a GLOB object, which is a huge GLOB objects, LOB objects, and which is a huge table and indexes, we need to estimate the data value. Based on that, we need to plan for the data movement through that FTW or else DMS or else file-based transfer. And sixth steps, define downtime window and cutover strategy. So based on the criticality of the database. It is a tier 1 database or tier 2 database or tier 3 database. Based on that application downtime a window and cutover strategy, we need to plan accordingly. The zero downtime versus planned window. If it is very critical tier 1 database, that production critical tier 1 database, there won't be any intolerable downtime. So there is we need to go with that is the zero downtime migration window. And if there are the application teams provides some 30 minutes or 1 hour downtime window, so planned window, so we can perform like we can plan accordingly for the downtime window to cut our strategy. And 7 steps that build migration team. So we need to build a team for the database migration from the scratch, either DBA, developer, QA, project manager. So prior to that Oracle to PostgreSQL migration, we need to take into the consideration for the migration team from the DBA perspective, from the developer's perspective, from the QA analyst perspective, and the project manager perspective. We need to build a team. Application side, they should build a team also. And the 8th step, set up dev UAT PostgreSQL environment for testing. Prior to that Oracle to PostgreSQL migration, we need to perform for the dry run. For that, we need to set up for a RAT system, recovery system, real application testing system. For that, we need to set up a dev UAT Postgres environment for testing prior to that actual cutover migration. In this case, real application testing also we can perform. So first steps, set up a WT Postgres environment and do the dry run for 1 or 2 times and perform the RAT system, perform the RAT testing, real application testing. You can perform with that application team. And once it is set up, done, and you can do your Oracle to Postgres migration and environment testing and everything will be fine. Okay. For this assessment and planning part, you need to take into the key consideration row num versus limit. Oracle uses where row num less than number. PostgreSQL uses limit n. Every row num uses need rewriting. And second thing, connect by. Hierarchical queries need rewriting as with recursive CTAs in PostgreSQL, that is high effort. And another one, AWS analysis. Capture top 50 SQL by elapsed time. These need manual review and explain plan comparison post migration. This is crucial steps we need to take into the key consideration and AWS analysis. And the another one, migration score. Score 0 to 30, fast migration. Score 31 to 60, weeks. Score 60 plus requires significant code rewrite budget. So that migration score, it is very crucial, very, very important key consideration here. Okay, next one in this assessment and planning, assessment command here, install Oracle PG open install Oracle PG, run full assessment, generate migration score. Oracle PG double slash double hyphen type table hyphen access forward slash hyphen T table view sequence trigger procedure function package type forward slash hyphen O assessment underscore report and dot HTML. So first assessment, we need to install the Oracle PG tool, and then we need to analyze a full assessment for the table. It will be generated under assessment underscore report HTML, so we can analyze. Check the score. 0 easy, 100 equal to complex. Cost unit 1 is trivial and 5 is moderate, 10 is complete conversion. Okay, so Oracle Object Inventory SQL select object type count and count from DBA object where owner group by object underscore type where group comment type, right? All right. So these are all the assessment command. First we need to perform first assessment and planning. So key tools. What are the key tools using these steps? The phase 1. The key tools Oracle PG full assessment plus schema code export. This is license free GPL. Okay. And AWS SCT schema conversion tool with a report. This is also license free with the AWS. Exachk Oracle Health Check pre-migration. This is MIOS download. This is my Oracle support download. You can perform. This is required license. Exachk and AWS reports. Workload analysis top SQL capture. This is required Oracle diagrams tuning pack. This is also this is licensed pack required AWS reports. These are all the key tools required in this first phase. Okay. Migration timeline, typical schedule. That timeline varies by database size and complexity score. Based on that database size and complexity score, the timelines will vary. So here, week 1 and 2 assessment. Okay, that first 1 or 2 weeks, the assessment and planning will take into the place. Oracle PG assessment run, object inventory, AWS analysis, team formation, target environment setup. And week 3rd and 4th, schema and code. Either it is DDL conversion, PLSQL to pgSQL, package decomposition, jobs equal to pg underscore crown, dev environment testing. These are all that part can take into the consideration 3rd and 4th week. And week 5th and 6th, initial load. For the dev environment testing, we need to test the initial load during the dry run part, like FTW. Based on that table size, we need to decide it is either it is FTW or DMS setup. And full data transfer, index rebuild, vacuum analyze, first count check. And week 7th and 8th, the CDC and test data capture and testing. DBAs CDC live, regression testing, performance tuning, UAT round 1 and leg monitoring. So week 4, week 7th and 8th, we will be doing the CDC and testing phase. And week 9th and 10th, validation. Full row counts, checksum validation, business UAT, performance benchmarks, sign off, obtained, and finally week 11th, cutover. Final rehearsal, maintenance window, DNS pull switch, and 4-hour monitoring, Oracle standby 48 hours. So these are all the timelines for the typical schedule for the Oracle to PostgreSQL migration from the assessment to cutover. So it is completely required based on your database size and complexity. So it will be week 1 to 11th week we can perform the cutover. Key consideration, critical factors that determine migration success. Schema design differences. PostgreSQL and Oracle handle schema object differently. Plan for each of these conversion during design phase. Oracle packages to PostgreSQL schema plus grouped function. Oracle synonyms goes to search underscore path or views. Oracle database links goes to PostgreSQL FTW extension. Oracle row ID goes to PostgreSQL CT ID, not recommended for application use. Oracle global temp table goes to PostgreSQL temp tables different scope. These are the schema design differences. Performance oriented differences like performance tuning after migration. PostgreSQL query planner differs from Oracle CBU. Queries that were fast in Oracle may need index or query tuning. Row vacuum analyze identify after data load. Review top 50 AWS queries. Recreate execution plans. Set work underscore mem per query type, joins and sorts. Use pg underscore state underscore statements to find slow queries post migration. Tune shared underscore buffer 20% of the RAM. Effective underscore cache underscore size 70% of the RAM. These are all the key consideration performance tuning after migration. And then transaction and locking differences. PostgreSQL uses MVCC readers never block writers, but locking semantics differ in important ways. Oracle read committed goes to PostgreSQL read committed similar. Oracle uses row level locking, but PG uses page level for some apps. PostgreSQL DDL alter table takes access exclusive lock. Plan carefully. Use skip locked for queue style application. Dead tuples accumulates. Auto vacuum must be properly configured. This is for the transaction and locking differences key consideration. And then security and authentication. MAP Oracle uses role model to PostgreSQL role-based access control system. Oracle profile goes to PostgreSQL pg underscore hva.conf plus scram SHA 256. Oracle VPD row level security goes to PostgreSQL RLS policies. Oracle fine-grained auditing goes to PG audit extension. Oracle transparent data encryption goes to PostgreSQL TDE, PG TDE extension or file system encryption. Map Oracle connect role to PostgreSQL logging privileges. These are all the key consideration of the security and authentication. Coming to the data validation strategy, consider key consideration part. Never skip data validation. A systematic approach ensures zero data loss and business continuity. Level 1, row counts per table automated every 6 hours during CDC. Level 2, checksum on key columns, MDS aggregate comparison. Level 3, business rule validation, report outputs match exactly. Level 4, application regression test, shoot greater than 95% pass rate required. Level 5, UAT sign off by business stakeholders. These are all the key considerations for the data validation strategy. And then essential Postgres SQL extension. What are all the key essential Postgres extension required for this Oracle to PostgreSQL conversion, data migration? Install these extensions immediately after setting up the target PostgreSQL instances. So dev UAT, whenever we are setting up that system, right, we need to install these extensions immediately after setting up the system, target PostgreSQL instance. Oracle underscore FTW, connect to Oracle during migration and for FTW. PG underscore cron replaces Oracle DBMS scheduler jobs. PG audit logging for compliance replaces Oracle FGA. PG underscore state underscore statements, query performance monitoring. PG underscore partman, automatic partitioning management. Post GAI, if it is Oracle SOD geometry, spatial data exist. These are the essential PostgreSQL extensions for the key consideration, and you need to install while setting up your DBAs system, target PostgreSQL instance. And coming to that high risk conversion item, the Oracle features require the most manual effort and testing, allocate 3x more time than expected. Connect by prayer goes with recursive complex rewrites. Oracle packages with package level variables state. Bulk collect for all bulk operation. Oracle specific analytic function first underscore value, ignore nulls, etc. Oracle merge statement goes to PostgreSQL insert on conflict. DBMS underscore crypto slash util underscore file slash util underscore HTTP goes to extension alternative. These are all the key considerations for high risk conversion rate. And then coming to the low rollback and contingency planning. Always have a tested rollback plan. The ability to roll back gives confidence to proceed with the cutover. So what you need to take into the consideration, keep Oracle in read only for minimum 48 hours post cutover. Define clear rollback triggers, error rate greater than 55%, response time greater than 3x baseline. Test rollback procedure in full rehearsal before real cutover. Reverse CDC compatibility PostgreSQL to Oracle for data written post cutover. Maintain application dual write compatibility capability for first 24 hours if possible. So these are all the rollback and the contingency planning, and you need to take into the key consideration. Oracle to PostgreSQL object mapping. How the objects are mapping with Oracle to PostgreSQL. Oracle object, PostgreSQL equivalent, and effort and nodes. Okay. So table, it is same thing. Table, low effort and nodes, it is low. Auto PG auto converts types. Index, it is B-tree, either gen or GAist. Low, some concept, different type of option. Sequence, it is sequence as our identity column. That effort, it is low, generated always as identity preferred. View, as a view, it is also low effort and mostly auto converts. Material is view, it is medium, references syntax differ slightly. Procedure, it is function PL slash pgSQL. This is also effort medium. Syntax differences, no pragma. And function is a PL underscore pgSQL, medium effort, return versus returns keyword. Package is a schema plus grouped functions. It is high effort, no direct equivalent, package state lost. Trigger plus function, medium effort, pg triggers call a separate function. Synonym, search underscore path slash view or alter table set schema. It is a medium effort per user use cases. Database link, Postgres underscore FTW foreign server. It is medium effort for FTW setup required. Partition, range and list. It is declarative partition by the range list. It is also medium effort, syntax difference, interval to pg underscore pathsman. Here it is a DBAs scheduler job. It is cron, pg underscore cron extension, medium effort, cron, syntax different approach. DBA underscore output, rise notice, rise log. It is low effort, simple replacement. Connect by prior with recursive city. It is high effort, complete query rewrite needed. Row it is limit slash row num and row underscore number or over. It is medium effort. Pattern, it is specific rewrite. Decode, case, when, and then or end. It is low effort, straightforward replacement. NVL functions a comma b or it is QLS a comma b. It is low effort, direct replacement. Sysdate, it is now or current timestamp, low direct replacement. So substring, it is substring as one n or substring as one n. It is also low effort. PostgreSQL supports both. To-char date or format, it is to-char date format. Format codes differ. It is also required for the medium efforts, format storing. Differences M versus NM is same, but MI is NM versus minus. Minutes. Merge into it is insert or on conflict do update. It is medium effort, syntax complexity different. Bulk collect or formal for all set based SQL or on set. It is high effort reassign redesign set operations. BPD fine grained security, it is row level security RLS, it is medium effort, different implementation approach. Oracle text, full text, TS vector or TS query or gene indexes, it is medium effort, native PG full text search. What do you need for the migration checklist? You can see the pre-migration checklist and migration and go live. So when you click one by one, it is required that Oracle PG assessment completed, migration score documented, all Oracle objects, inventories table, procedures, packages, triggers, AWS top 50 SQL captured and reviewed, target PostgreSQL provisioned and configured, extension installed, Oracle underscore FDW, PG underscore CRAN, PG added, PG state and statements, migration item, team identified and roles assigned, rollback plan documented and tested, cutover strategy agreed, blue, green or DNS pool, Oracle supplemental logging enabled, schema conversion completed and tested and dev environment, PLSQL and PL pgSQL conversion done and unit tested, PG underscore HPA configuration and the PG PostgreSQL conf tuned for production lead. These are all the pre-migration steps and post-migration and go live. During that migration and go live steps, initial full data load completed successfully. All index rebuilds and vacuum analyze run on all tables. CDC and WZM running and log monitored less than 30 seconds. Row count validation passed all tables. Checksum validation passed for all critical tables. application regression test suite greater than 90% pass rate, UAT completed, business stakeholders signed off, performance benchmark with 110% of the Oracle baselines, cutover reversal completed, timed and documented, cutover executed app traffic and PostgreSQL, 4-hour post cutover monitor completed, no critical issues. Oracle kept in read only on for 48 hours, then decommissioned. So these are all the post migration go live checklist. All right. So these are all the steps for the complete migration process. So we have covered, right? And then phase 2, that schema conversion, or to PG. Step-by-step process here. Export Oracle DDL tables into the table types. Convert Oracle data types Postgres equivalents to numeric varchar text. Convert sequence to generated always identify generating create sequence. Rewrite connect by hierarchical queries with recursive CTEs. Convert Oracle partitioning interval list range to PostgreSQL declarative partition. Replace synonyms with schema, search, path, or views. Replace database link with Postgres FTW foreign data wrapper. Test schema in target PostgreSQL, fix errors iteratively. So Oracle Postgres type mappings, Oracle type number, here it number PS exact match, varchar through number, text or varcharian text preferred, date, it is time, Oracle date has time, CLOB text no size limit for PG, PLOB BYTEA binary storage, raw and BYTEA binary equivalent, nvarchar text, PG is always Unicode, float, binary underscore float, it is double precision, approximate numeric, XML type, XML, native XML type, SDO geometry, post GIS, need post GIS extension. Schema conversion script, and here is that actual schema conversion script. Aura to PG, as you have already installed this tool extension, Aura to PG, type table -o tables.sql. Aura to PG type sequence -o sequences.sql. Aura to PG type index-o indexes.sql. Not to PG type type constraint-o constraint.sql, or to PG type view-o views.sql. So apply to PostgreSQL PG PSQL-u Postgres-d target db-f tables.sql. So we need to run this, what we have collected, that table indexes, synonyms, in sequences, constants, everything we need to run as a target machine, target database. PSQL-u Postgres user-d the target database name -f the table.sql where we have collected here. So in here, the Oracle date trap. Oracle date stores date and time. PostgreSQL date is the date only. Always use timestamp in PostgreSQL to avoid data loss. You need to take into the key consideration, key point, very crucial and important, avoiding the data loss. You need to take a very important point here. It is Oracle date has date and time. Okay, but PostgreSQL date is the only date only. There is no timestamp. That is what we need to always use timestamp in PostgreSQL to avoid data loss. And another case sensitivity, Oracle is case insensitivity for identifiers But PostgreSQL lowercases unquoted names watch for quoted mixed case identifiers. So here another important consideration, case sensitivity. Okay, and then phase 3, code conversion PLSQL to PL pgSQL. Okay, so key the schema conversion or to PG tools used or to PG AWS SCT pgloader. Okay, and phase 3, code conversion PL and PL SQL to PL pgSQL. Tools used or to pgSQL learners manual conversion. Okay, so what it is step-by-step process involved here for this conversion. Export all procedure function packages triggers with Oracle PG type procedure. Convert Oracle pages to PostgreSQL schema plus function no direct package equivalent. Replace dbmod underscore output dot put underscore line with cause notice, rise notice. Replace sysdate slash systimestamp with now or current underscore timestamp. Replace NVL function with coalesce or decode with case when. Rewrite bulk collect slash for all as a Postgres set based on operation. Replace row num with row underscore number over or limit. Convert Oracle ref cursor to PostgreSQL ref cursor or returns table. Replace dbm underscore scheduler jobs with the p underscore cron extension. Test each stored procedure in isolation with the unit test. Here is the PLSQL versus PL pgSQL mapping. You have to create that the procedure like this way and in Oracle, but on PostgreSQL it is creating the same thing at big integer. Okay, here it is not as a big integer, but here it is big integer return as a not found, and these are all the way we need to create that mapping, procedure mapping in Oracle to PG PostgreSQL. Oracle packages no direct equivalent split into schemas, function, packages, state, global variables needs rethinking. And bulk collect replace with set and set based SQL, PG process sets natively, row by row loops in PL pgSQL are slow. So these are all the consideration. So these are all the step-by-step process for the phase 3. And phase 4, coming to the phase 4, initial data load. What are the tools we are using? FTW, PG underscore dump, AWS DMS, or auto PG, hyphen type and copy. So these are the tools we are going to use in the initial load phase. It is phase 4. Okay. So for phase 4 consideration, initial load and FTW and DMS as a bulk transfer. Step-by-step process, what are the step-by-step process involved? Step number 1, disable triggers and foreign key consideration on target for load speed. Drop indexes on target tables before loading, recreate the after load. Number 3, export data from Oracle using Oracle PG type copy or Oracle data pump. This extension or tools we need to use. Use copy command for fast bulk load into PostgreSQL 10x faster than insert. For large tables greater than 1 TB, use AWS DML full load or Oracle underscore FTW parallel fetch. Load large tables in parallel, split by partition key or row ID range. Re-enable constraints, rebuild indexes, use reindex concurrently. Run vacuum analyze on all loaded tables to updated statistics. So these are all the initial load, data load, FTW or DMS step-by-step process involved. Load strategy comparison, method, speed are best for, okay. Oracle underscore FTW, that is insert or select, this is medium speed, direct transfer, small, medium tables. This is used for Oracle FT underscore FTW, it is used for small or medium tables, and the speed it is medium. Oracle PG copy format, it is fast, any size, file based. AWS DML full load, it is very fast, AWS hosted environments. Oracle data pump plus PG underscore restore, it is medium, air gapped networks. PG loader, it is fast, parallel option, self-contained. So these are all the load strategy comparison. Coming to that FTW initial load script, for that FTW initial load, you need to create an extension Oracle underscore FTW and create a server the source foreign data wrapper Oracle FTW option Oracle host and that Oracle connection strength. Create user mapping for Postgres for Oracle underscore source option Oracle user password and import foreign schema app underscore one for from server Oracle source into Oracle staging. Insert into the customer, select star from Oracle staging customers, and then finally load the data. Parallel load with the ranges, split into parallel SQL session by 10 ranges. Insert into order, select star from Oracle staging orders, where order ID between 1 and 2, 50 lakhs. Okay. So these are all the TW initial load script. And performance tuning, like you can monitor you performance tuning consideration, you need to set up like temporarily increase for the load speed, set maintenance underscore work underscore mem equal to 4 GB, set max underscore val underscore size is 8 GB. Disable val logging for initial load unlocked. Alter table big underscore table set unlocked. Load data here. Alter table big table set logged. After load, update statistics. Vacuum analyze customers. Vacuum analyze orders. So this is performance tuning consideration. Okay. So this is involved for that initial data load and FTW and DMS bulk transfers for the phase 4 initial data loads. Okay. And coming to that phase 5 CDC, which is used tools for Debezium, AWS DMS, Golden Gate, PG Logic. Let's see the step-by-step process. So CDC, change data capture, zero downtime key. So step-by-step process involved. Number one, enable Oracle supplemental logging for all migrated tables. Number two, configure Debezium Oracle connector or AWS DMS CDC task pointing to Oracle log miner. Number three, start CDC after initial load completes. Capture all changes from load start SCM. Number four, CDC events stream through Kafka topic, Debezium or DMS replication instance. Number five, apply changes to PostgreSQL target, insert, update, delete, replayed in order. Number six, monitoring replication log. Target must stay with 30 seconds of source. Number seven, run side by side validation queries on both databases to verify consistency. Number eight, keep CDC running until cutover day, then flush final changes on switch. So these are all the step-by-step process for the CDC change data capture for the phase 4. CDC tools comparison. The tool, transport, and latency. WCM, Kafka topics, it is less than 1 second latency. And tool AWS DMS replication in seconds. Golden Gate, Direct or Kafka, it is sub-second latency. pglogical, it is used for the transport logical replication and it is latency sub-second. And streaming, and it is the latency also sub-second. So Debian CDC configuration, how we can configure Debian Oracle connection config like name Oracle migration CDC connection dot class IO Debian connector Oracle connector Oracle dot database dot host name Oracle host database port 1521 database name Azure lab or DBA hub database user log miner user table include list. You have to include that schema with the table name app underscore customer, app underscore header, app underscore products, snapshot underscore mode schema only. So use schema only since initial load done via FTW. Log underscore mining in strategic to online catalog. Database history Kafka Bootstrap servers Kafka 9092. This is the Debian GDB configuration. The Oracle prerequisites Oracle enable supplemental logging, so you need to change this Oracle side. Oracle database add supplemental log data. Enable for all columns of migrated tables. Alter table of customers add supplemental log data all columns. And create log miner users to Debian. Create a user log miner user. Identify by password. Grant logging to the log miner user. Grant select on database to log miner users. Grant select on log to log miner user. This is Oracle prerequisites we need to fulfill. So these are all for CDC, change data capture in the phase 5. And coming to that phase 6, data transformation. So the tools involved in this phase, DBT, Python ETL, PG underscore transform function. So we can see that the data transformation step-by-step process. Number 1, convert the Oracle date columns with time to timestamp in PostgreSQL. We cannot use the same date columns because there won't be date column. It's not coming up with the timestamp in the PostgreSQL. So there is a possibilities to data loss. So in this case, we need to convert date columns with time to timestamp in PostgreSQL. And number 2, transform character and trailing spaces are trimmed to text values. Number 3, convert raw blob binaries data to BYTEA format using encodes and decode. By number 4, reformat number 1, 0 Boolean columns to PostgreSQL Boolean. Number 5, hence null semantics. Oracle treats as null. PostgreSQL does not. Number 6, normalize character encoding. Ensure UTF-8 consistency throughout. Number 7, transform NLS date format string to PostgreSQL to char format codes. Critical differences to handle. Empty string equal to null. Oracle insert stores null. PostgreSQL is an empty string. All empty string goes to null. Conversion must be explicit. Oracle date has time. Oracle date equal to date plus time. PostgreSQL date is the date only. Always map Oracle date to PostgreSQL timestamp. Please make a note of it. And char padding. Oracle char 10 pads with the spaces. PostgreSQL char 10 also pads, but comparison may differ. Use text and trim. And NLS setting. Oracle NLS underscore date underscore format of affect implicit date conversion. PostgreSQL uses date style set explicitly in sessions or config. So these are all the critical difference to handle. So this is very, very critical, these 4 points. Transformation queries, PostgreSQL common transformation pixel, fix empty strings versus null, suppose differences. Update customer set middle underscore name equal to null, where middle underscore name equal to double quote. Convert number 1 to Boolean. Alter table users add column is active Boolean. Update user is set to active is that is active one. Alter table user drop column is active. Alter table user rename is active bool to is active. Trim car trailing spaces. Update products set category trim or trim category where category equal to does not equal to or trim category. So these are all the phase 6 data transformation quality gate step-by-step process involved. Okay. So in this case, very critical differences you need to we have addressed. You need to take into the consideration. This is very, very important during the Oracle and PostgreSQL data migration. And coming to that for phase 7, data validation. In this phase, what are the tools used? Oracle PG, type, test, PG compare, custom SQL. So in these steps, data validation, go, no go, gate. Okay. What is the step-by-step process involved? Number 1, row count validation. Every table must match exactly between Oracle and PostgreSQL. Number 2, checksum validation. Has aggregate for key columns to detect data corruption. Number 3, business rule validation. Run critical business queries on both DBs, compare results. Number 4, referential integrity checks. All FK relationship still hold after migration. Number 5, run application regression test suit against PostgreSQL target. Number 6, performance baselines. Top 50 critical queries must run within 110% of Oracle time. Number 7, UAT, user acceptance testing. Business stakeholders validity, key reports and workflows. Number 8, sign off document from all team before scheduling cutover. These are all the data validation step-by-step process. And what is the validation scripts involved here? For row count, checksum, validation, Oracle generate row counts, selects table name, row count from states, from DBA tables where app order by table name. But PostgreSQL match row counts like select the state, schema name, table name, and n underscore live to estimate rows, pg underscore size pretty, pg underscore total underscore represent size schema name and total name as a size from pg state user table ordered by n underscore live underscore describes. So you execute exact count comparison query with this. You can use this exact query comparison query like select count star from the Oracle underscore state income customer as Oracle count. Select count star from the customer as a PG underscore count. Select count star from the Oracle staging customer minus select count star from the customer as a difference. So this is exact count comparison query for both DBs. Here step stop if count mismatch. Any row count mismatch must be investigated and resolved prior to that cutover. Zero intolerance for data loss. Okay, very crucial and very key, very important. Take into the consideration. Stop if count mismatch. Count mismatch, it is very crucial. Cannot be intolerance. There won't be any zero tolerance for data loss, right? So stop if count mismatch. Validation report. Generate is signed validation report. Business, DBA and dev leads must sign off before go live is approved. So validation report we need to generate and provide to that application DBA. All the stakeholders we need to get approved before go into that live. Okay. These are all the phase 7 data validation. Go, no go, right? And coming to that last phase, cutover and go live. Strategy, blue, green or DNS switch and connection port. So what are the key steps are cutover and go live part? This is that D-Day. Cutover runbooks step by step. Schedule maintenance window even for zero downtime. Plan a 15 minutes rollback window. Okay. Number two, freeze application. Put application into read-only mode or enable maintenance page. Number three, wait for CDG lag to reach zero. Confirm PostgreSQL is 100% caught up. Number four, run final row count validation across all critical tables. Number five, stop CDC and the BCM connector. No more changes from Oracle. Number six, update connection pool application config to point into PostgreSQL. Number seven, update DNS or load balancer and point to PostgreSQL cluster. Number eight, remove maintenance page, release application traffic to PostgreSQL. Number nine, monitor query performance, error rates, connection counts for 4 hours. Number 10, keep Oracle in read-only for 48 hours as a rollback, failback, then decommission. So these are all the cutover runbook step by step. But what are the cutover strategies involved here? Strategy, downtime, and risk. Blue, green switch. Approximately 5 minutes downtime. Low risk, instant rollback. DNS cutover. It is less than 0 TTL based, medium risk, TTL delay. Connection pool redirect, there is zero downtime. The risk low, PG bouncer target switch. And feature flag rollout, zero downtime, very low risk, gradual traffic shift. Here, rollback plan involved. If rollback needed within 48 hours of cutover, step 1, re-enable Oracle as a read write target. So step 2, reverse CDC, PostgreSQL to Oracle, use PG logical or custom triggers. Step 3, update connection string back to Oracle. Step 4, investigate root cause. What is the issue? Why we cannot be able to stay in that PostgreSQL migration, that target site? We need to start investigate and find the RCA. Step 5, fix and reattempt cutover. Again, we need to redo all the steps, whatever we do the previously. So, fix and reattempt the cutover. PostgreSQL check if system is healthy. Select count star state from VG_state activity where date name, current date, site, and state. And monitor error rate after cutover. Select query calls mean exact time, steady dev execute time from PG state statements where mean and execute time greater than or 10,000 queries minus double queries greater than 1 second. Order by mean execute time task limit 20. Okay, so these are all the cutover and go live, the final D-Day. Okay, so in this so far we have analyzed and discussed enterprise data migration, Oracle to PostgreSQL migration architecture step by step, a complete walkthrough and complete step-by-step migration blueprint from the scratch to stage-by-step maintenance progress to phase 1 to phase 7 we have discussed. Okay, here in the planning, we have completely and thoroughly discussed these are all the migration architecture workflow for Oracle to PostgreSQL database migration. Hope this migration architecture will help you for your real-time database, Oracle to database, PostgreSQL database migration. And keep watch this space for I am going to perform Oracle to PostgreSQL migration in my upcoming videos. Okay, until then, stay tuned and please do subscribe and share your networks. This is for your AA DBA Hub host, and it's your channel, and I'm very pleased to share the knowledge. And AA DBA Hub, it's a knowledge sharing channel as well as the DBA excellence. Until then, stay tuned. Bye. Thank you.